Hello everyone, this is INE Foundation Lab 2, section 5.3 BGP. Okay, before I conclude this section, let me explain BGP concept and I will come back and configure this section. Okay, let me start by BGP attribute and path selection. Okay, as we know, iBGPs select best path with lowest metric or lowest cost, but BGP selects best path based on list of attributes. Attributes are weight, local preference, originate, AS-Path length, origin code, med, oldest path, and router ID. Okay, iBGP rule. What is iBGP rule? iBGP will not advertise BGP advertisement length from one iBGP neighbor to another iBGP neighbor. This is for preventing loop. And for this reason, we have to configure either full mesh in iBGP part of our section. We have to configure with either full mesh on our router, full mesh connectivity, or we have to configure BGP route reflector. Okay, BGP next hop attribute. By default, iBGP do not change next hop attribute to avoid routing loops. And if we want to change, we have to use next hop set command on boundary routers. Okay, here if this is eBGP and this is iBGP inside this AS. If switch 4 advertise its route to R10 and R10 advertise it to R3, R3 will see this route next up as this interface. Interface will run 124. We can change on a boundary router. This is R10 is our boundary router. This is R10. We have to configure next RCF on R10. Okay, BGP synchronization. This is the like iBGP rule, but instead of iBGP we have eBGP. Okay, what is BGP synchronization? BGP will not advertise prefix static length from iBGP neighbor to an eBGP neighbor. If the prefix cannot be validated, this is validated mark and this is base mark in its iBGP. Prefix has to be in its iBGPs before it can be advertised to an eBGP neighbor. Okay, it says BGP will not advertise to eBGP if that route is not validated in iBGP. That route should be validated in iBGP if synchronization is enabled. Nowadays, synchronization is disabled, and the route does not have to be validated in IGPs. Okay, this is synchronization rule. Okay, let's start by BGP section. In this situation, a prefix will be ignored for path selection. One of them is non-valid next hop. If BGP doesn't have valid next hop, it will be ignored. The BGP path selection will be ignored. The other one is BGP synchronization is enabled and prefix is not in IGP table. In this situation, prefix will be ignored. And in third one, AS-Path loop. Prefix from the neighbor that has the local AS number in the AS-Path attribute are dropped. In other words, if we see our local AS in AS-Path attribute that we receive from our neighbor, that path will be there, original. Okay, our first BGP path attribute is weight. Highest weight is preferred. Weight is local to our order. This is locally. This is Cisco proprietary. We only have weight in our on Cisco devices. Is not transported along BGP update. And this is important. The default value is 0 for all routes that are not originated. Another, if routes are not originated, we have weight of 0. And Cisco Route attached weight of 32,070.68 that are locally originated. And if learned from eBGP or iBGP, we have weight of 0. Okay, for locally originated prefix, we have this weight. And if we learn from eBGP or iBGP, we have weight of 0. This is not originated, and we have weight of 0. Okay, we can conquer weight in two ways. One is for, by using weight command. This is neighbor, remote IP address, and weight, weight value. And the other one is by using route map. This is inbound route map. We conquer neighbor, remote IP address, route map, and inbound. This is inbound. Weight is for inbound route. Third one is second one is local preference. This is highest local preference either highest. It is well-known discretionary, and default value is 100. iBGP learned prefix have to develop local preference on 100. Okay, it is using our autonomous system and direction between iBGP router. And you send our internal BGP routes in our autonomous system. This is prepend. Is not exchanging between external BGP router. And when a router learns a prefix from neighbor in another autonomous system, the update will not contain our local preferred attribute. But when router learns prefix from neighbor within our local AS, the update will do contain local preference. If it is local within our local AS, it will contain local preference attribute. But this is the same. This is not Mondays, and local preference is outbound either. This is for outbound external path, BGP path. You can configure local preference in two ways. One is from this command BGP default local preference value, or the other one is the other way is from the other one to configure local preference is by using route map. Neighbor IP address route map or route map. This is inbound. Local preference is inbound in the weight. Local preference inbound. And third one is originate. Prefer the path that is locally originated. The router originated. A BGP router will prefer a route that is installed in BGP by itself or another router installed in BGP. Okay, if the route is locally originated, it means we will see next hop of this 0, 0, 0, and 0. Let me explain the show this on RT. If I do show IP BGP, let's start R1. Show IP BGP. Okay, this is locally originated. Yeah, this is 0, 0, 0, and 0. And we have weight of this. Locally originated prefix have the default weight value of this one. This is local weight value. Preferred third one, it will prefer path that is locally originated. Over route that another router installed into BGP. Okay, it can be installed button in BGP by using network, aggregate, or redistribution commands. Okay, fourth one is AS-Path length. BGP will prefer shortest AS-Path, and we can manipulate this by using AS-Path prepending. This is we can use we can create a route map and use set AS-Path prepend command in our route map. And this is important. AS-Path length is outbound, not inbound. AS-Path is outbound, but this local preference is inbound. And origin code. The lowest origin code is preferred. We have IGP, eGP, and incomplete. And origin code is well known and mandatory. If we do, let me show. This is this one. If it's question mark and I, we have all question mark. If we see all, it is originated using network or aggregate address command. And if we see question mark, it means it is incomplete, meaning that the source couldn't be determined and it is redistributed into BGP. E is not, meaning that prefix was received from eBGP and it's not working anymore. It's not using it anymore. Nowadays, this is legacy mode. I is preferred over incomplete. This is lowest origin code. I is lowest than question mark. On med, we have med attribute. Lowest med is preferred. This is optional and non-transitive. And med can be used to advertise to your neighbors how they should enter your AS. And it is used on eBGP pairing links to select entry point to our neighboring ASs. This is the same. You can influence incoming traffic from neighboring, and this is not non-transitive. Mandatory influence. Autonomous can, okay. The main attribute cannot influence the voting decision of more remote autonomous system. Okay, this is important. BGP router by default compare the main attribute of routes that come from the same ASs. We can change this default behavior by BGP deterministic method or BGP always compare method commands. This is important to understand. By default, compare method attribute that come from same ASs. Okay, the Cisco has a document for the status method and always compare method. If you want, you can read this document on Cisco website. We can configure. This is we can configure route map, and this is outbound. Made is outbound either, and it's prefer eBGP path or iBGP path. This is and shortest iBGP path to BGP next hop, and all the preferred path we receive it first, the oldest path, and last one. If this is our tiebreaker, this is not this is before last one. This is water ID. Preferred path with the lowest neighbor water ID, and last one preferred path with the lowest neighbor IP address. If we have same water ID, then our tiebreaker is preferred path with the lowest neighbor IP address. Okay, this was BGP path selection. And let me aggregation. Okay, BGP route aggregation. Okay, if we use aggregate address, with that BGP aggregation has various options. If we don't use any option and use aggregate address and or mask, if we don't use any option, there is no inheritance of individual routes attributes such as AS-Path or community. This will cause a loss of continuity if we don't use any option. And all more specific routes summarized by aggregate routes are advertised. And if we don't use any option, for example, summary only and AS set, and this all more specific route will be advertised. We will see all we will see aggregate route plus more specific routes. Okay, the aggregate address is advertised to our neighbor as long as it is part of aggregate address in our BGP table whatever. So we can use null. If we don't have that route, we can use null 0 to be part of our aggregate address. Okay, as I said before, if we don't use any option, it will advertise more specific route plus our aggregate route. And if we use summary only option, aggregate and summary only, it will suppress more specific routes of class interval routing serial route, and advertise only an aggregate route. And suppressed routes are shown by S in our show BGP command. We will see in this part. I will show you how it is working. Okay, if we use summary only, we will see. We will not see our more specific route. We only see aggregate route. We only see aggregate route without more specific route if we use summary only option. Okay, this is important. Summary only along with suppressed map does not have any effect. We usually use summary only with unsuppressed map. With unsuppressed map. Okay, summary only with does not have with suppressed map does not have any effect. Okay, AS set option. This is if we use AS set, it inherits attribute from more specific routes. It will create an aggregate route, aggregate address with mathematical set of autonomous system, and some others are AS-Path attribute to allow individual routes. And the set option contains information about each individual route that are aggregate some others. Okay, we will see if we use AS set, we will see our AS-Path attributes along all individual routes, which summarize our AS-Path attributes. And we have suppressed map option and unsuppressed map. Okay, as I said before, summary only will not have any effect with suppressed map if you use summary only. Suppressed map, for using suppressed map, we use suppressed map name, we create suppressed map or route map. And what it is means, suppressed map means more specific routes that are suppressed, more specific routes that the suppressed map suppresses are not advertised. Okay, if we use suppressed map, more specific route will not advertise. This is why summary only will not have any effect with suppressed map. This is like summary only. If we use suppressed map, more specific route will not advertise. We only have aggregate route. And we have for creating suppressed map, we create IP prefix. We use IP prefix list route map and create our suppressed map. And we have unsuppressed map option. Okay, if we subset of our suppressed route needs to be made available or need to be advertised. If we want to advertise our suppressed routes, we use unsuppressed map. We usually use unsuppressed with summary only. summary only will surface, and if we want to see one part of our network to see a more specific route, we use on surface map. This is our surface map. This is our summary only with on surface map. Okay, summary will surface our excuse me, our route, and on surface will advertise our surface route. Yes, if we want to. And we have attribute map, and last one is advertise map. Attribute map is used to change our attribute of our aggregate route. If we need to remove attributes or set our attribute to aggregate route, we'll use attribute map. And advertise map. This is BGP conditional advertisement feature. This is like if we want to advertise that prefix, if for example, if that prefix exists in our router, then we will use advertise map. The BGP conditional advertisement feature uses the we use non-exit map and advertise map keyword. Okay, if we see this okay, this is confirmed by BGP conditional advertisement. This is great website for only this advertisement example. This is good example. If that would exist, then it will advertise that route. BGP conditional advertisement. And this is our BGP Route Aggregation, and this is our BGP path algorithms. This is updated recently, this document. Okay, this is our BGP path selection and aggregation concept. We have to understand what to do in this section. Okay, now let's configure this section. Okay, conquer new loop back 100 on switch 3 and switch 4, and this IP address. Welcome to loop back 100 on switch 3 and switch 4 with this IP address. Okay, let's configure loopbacks on switch 3, config T, interface loopback 100 IP add this 156 100 100 100 and choose 32 bit. Just switch 3 and switch 4. Okay, these are loop back. Okay, add method the new loop any cast loop back into BGP on switch 3 and switch 4. Okay, what is any cast? This is any cast address allocated to set up interface typically belong to different waters. This is not when a packet is destined to any cast, it is delivered to closest interface. This is any cast address. Okay, we have to advertise into switch into BGP in switch 3 and switch 4. Okay, we can use network or redispute. We have to use network command here. We have to only advertise. Okay, on switch 3 ensure on pipe section not a BGP. Do short on. Excuse me. Okay, this is for the BGP 300. This is MPBGP. I have to go on the address family IPv4 and type advertise this network. This is 32-bit mask. And that's it. Same on switch 4. Do shut on pipe section to the BGP with the BGP 400 address family IPv4 and network. This is 32-bit mask. Yeah. Okay, now let's verify. Show IPv2, show IPBGP, show IPBGP. We have next hop of 000. This is locally originated by network command, and this is I. On switch 3, do show IPBGP. This is I, weight is 32,070.68, 0, and this is I. Next up, this is locally originated by network command. Local not learning from eBGP. These are learning from eBGP or iBGP. Okay. Okay, by only making changes on switch 3 and switch 4, ensure that traffic to this new network always exists via AS400. Let's see, AS400. Only we can only change on we have alert only to change on switch 3 and switch 4. And ensure traffic to this network, new network, this network all exists via AS400. Okay, let's see. I have advertisers on switch. If I do show IPBGP, this network, this is 0 local origin. This is our BGP router ID. Okay, let me. Okay, this is a BGP router ID. And on switch 4, do show IPBGP. This is 000 from this is local originator, weight is this, valid, and local best. And now let's see on R9 and R3. Show IPBGP. For the show IPBGP, we have this route. Do show IPBGP. Okay, R9 is can see this route via AS300. We have to configure so that it only exists via AS400. And let's check on R3. Show IPBGP. Route BGP. Okay, we have two paths. One is AS300, the other one is 400, and AS300 is selected as best. It is because it is last router ID, which is 23. 23 is lower down. If we have CR path selection, with the last BGP neighbor router ID. All other options are the same. Local preference made, and the tiebreaker is router ID on R3, and R3 is using switch 3 because switch 3 has lowest router ID. 23 is lower than 24. Okay, we have to change on either on switch 3 or switch 4 so that R3 will use that route via switch 4. Okay, here we can use BGP, can manipulate our AS-Path length by AS-Path prepend command. Okay, let's prepend I will prepend this AS 300 so that R3 will choose switch 4 over switch 3. Okay, yes, prepend is outbound. I have to configure route map and switch 3 and use outbound route map. Okay, let's create and switch 3. Create. I will first create prefix list. IP prefix list. Let's type it. Prepend. Permit 5. Permit. Well, this is what was this is our prefix list. Oh, I match this any case address. Okay, now create route map. Route map. Let's call this prefer switch 3. Permit 5, and I will match IP address of prefix list prepend. Okay, I will open this map with map. BGP on this BGP. I have to go on the address family. This is MPBGP. And let's see on neighbor IP address eBGP on switch 9. What do we show? IPBGP's show IP interface brief. This is 2, 3. This is our neighbor. Route map. On the route map name is prefer switch. Oh, forgot to prepend that route map. Let me prepend. Go to what a route map. I have matched it and I have to prepend is set. AS-Path prepend. Okay, here I am on switch 3. Our local AS is 300. I want to prepend this multiple times. This is AS-Path prepend. Okay, now I have to go what is 300. This formula before. One neighbor. Our route map is prefer, and this is outbound. This is outbound. Okay, do show iBGP. Is local. Now on R9, if I do a check on R9, show iBGP, I have this prepend. I have this without prepend. If I do show iBGP and this route, oops, and R9 will choose 400 as best because this is AS300 is prepended. This is our AS-Band length. Our AS-Band length is our tiebreaker here. and if I check on 3 show IP BGP this route, it is using 400 only one part. Okay, this is done. Okay, now we have to redistribute our prefix in the this range from eRGRP into BGP on switch 1. Okay, let's see where is switch 1. Topology. This is switch 1. We have eBGP. Switch open switch 1. Show IP route. We have eBGP. This is 56.1 and so on. Start with 56 plus and then dot 1. We have to use this prefix into BGP on switch 1, and this is 156.1.0.0/16. Okay, we have to distribute command network into BGP. Okay, let's go on. Let's first config T. Let's create IP prefix list. IP prefix is called eRGRP routes. Permit 156.1.0.0. That's not 16. It's usually less than this is maximum prefix length 24. Now we create route map. Route map. Call it eRGRP into BGP. Permit 5 and match IP address. Match IP address prefix list. This is our prefix list. Is the eRGRP route. Okay, I've created a prefix list. This range. This is eRGRP routes. And I've created route map. I match this prefix list, and I have to redistribute it this prefix into BGP. Do shutdown part section of the BGP file. I have to go on the address family and redistribute. Let's see what is eRGRP. Do show IP protocol. This is eRGRP 5. We have eRGRP 5 here. Yes, 5. Okay, redistribute. eRGRP 5 route map. So our route map is this one. Okay, now let's do show RP BGP. Okay, now because we have redistributed our eBGP rules, we will see this origin code. This is incomplete. This is, it means it is redistributed. IGP is over, it preferred over incomplete. Okay. Okay, we have distributed our eBGP routes in this range into BGP on switch 1. Done. And last part, configure aggregation. Configure an aggregate on switch 1 so that R1 receives this summary along with our more specific file distribution. Okay, R1 will have to receive summary route. This is plus more specific route file distribution. It means we have to use summary on. What is this? We have to use summary only option. Access R1 receives plus. Okay, with R1. This is always R1. We have to confirm switch 1. Okay, R1 we have to more specific routes. This is summary plus more specific. Okay, we have to use on surface map. On surface for R1. And the rest of internal BGP domain should only see aggregate. Okay, rest of network, all rest of network should only see aggregate, I guess. But R1 should see summary plus more specific route. Okay. Okay, summary only will suppress our route on our local router and advertise only aggregate route. This is our summary only feature. Okay, here on switch 1. Okay, Okay, here on switch on I will use aggregate address with summary only option. Let me explain this on here. On switch 1 I will use let's change from okay, on switch 1 I will use aggregate address with summary only. It will suppress our local route and will advertise only aggregate address to all our network. If I use a summary aggregate with summary only option, it will suppress our local router, suppress more specific route, and advertise only aggregate address to all BGP on our network. And but switch 1 should receive summary only with or more specific. Then I will use unsuppress toward R1. Then I will create unsuppress map, unsuppress map toward R1 with neighbor. Then R1 this is aggregate address plus more specific, because I'm doing unsuppress toward R1. Then all our BGP network will see aggregate address, but R1 will see aggregate address plus more specific route. This is why we normally use summary only with unsuppress map, because summary only command will suppress our local route and will advertise only aggregate. And if we want one part of our network to see more specific route, we use unsuppress map. Okay. Let's based on switch 1. Okay, let's first let me first do this. Let's come with this part. Rest of our internal level should see aggregate, only aggregate. Should see only aggregate. If we want to only aggregate, we have to summary option. Let's see summary option. All rest of them only see aggregate added. Okay. Here on the let's do shutdown pipe section with a BGP. With a BGP. I've gone the address family, then aggregate address, and I have to use address and a mask with summary only. Summary only will suppress our local route, internet domain route, and advertise only aggregate route. We will see S and show our BGP in our local router. subpath route option about this. Okay, let's see. Okay, let's do before I come do show IP BGP. I have these rules, ERGR rules, and let me aggregate, add this. I have to do this aggregate 0 0 255 255. This is mask, and I will use this is our options. I have advertise map, ASA, this composer, attribute map, route map. These are summary only and subpath map. Okay, let's use summary only, and if I do show IP BGP. Okay, now this ERGR rules are subset. This is a subpath map, and if I check IP BGP on R10, this is aggregate route. I only receive aggregate route on rest of our network. If I check on R1, show IP BGP, R1 is receiving aggregate route, and so on. Okay, now it says R1 should receive summary along with more specific prefix from redistribution. R1 should receive our subpath route. Okay, we can use on subpath map on switch 1. When it is less for configuring on subpath, we create a route map, then call it on subpath map. Permit 5. Okay, I have not much IP address prefixes. I have created before this, and before this is my prefix list is okay. Do show down. Okay, this is a prefix list. This is our eRGRP routes. So match IP address prefix list. This is our eRGRP routes. Permit 5. Okay. We are permitted into route map. Okay, route map on subpath map permit this, and on the to show 5 section for the BGP. Under the BGP, I just found my IPv4 and neighbor. This is our R1. Let's see R1. Show IP BGP. Show IP interface brief, and this side plan. This is R1. Switch 1, neighbor, and we have unsurpassed map. The route map to selectively unsurpassed surpassed routes. See there. Then what is our surface map? This is I have created a surface map here. The route map. Where is my route map? Oh, this is our surface map. I can create by route map. That's it. Enter. Now, if I check R1 show IP BGP, okay, now R1 will receive more specific route summary along with more specific route. R1 will receive all routes that has been suppressed by CH1. This is 39.0 and 0. But rest of our network will see only aggregate route. Show IP BGP. Rest of our network are receiving only aggregate route, but let's check on switch. Show IP BGP aggregate route, only aggregate, but R1 will receive only. R1 is receiving only. R1 is receiving more specific route plus summary, but rest of our network only receiving only aggregated. Okay, that's it. This is this was our 5.3 section. I hope you have enjoyed this video, and thank you for viewing.